Okay, everyone, we'll be talking about stability today. What exactly we mean by stability is that if there is any perturbation in the equilibrium state, you basically come back to the equilibrium state. We'll be examining the issue of stability with the help of phase diagrams where till now you were plotting x against time. So phase diagram is basically a diagram of x dot as against x. Okay, and the idea of stability is that you will look at this phase diagram, whatever the graph looks like, and you're going to identify the equilibrium state as one where x dot is equal to 0. That's how we examined equilibrium states earlier also. So whatever point where x dot is 0, that will constitute our equilibrium state, and then we will examine stability with respect to that. Okay. Also, we'll be examining stability specifically for this kind of an equation where x dot is equal to capital F of x. Now, as you can see, this is a special case of the first order linear differential equation, because we had described the first order linear differential equation as x dot equal to let's say f of t comma x. Now, the only difference that we have here in this equation is that this right hand side is independent of t. So this equation is basically a special case of our first order linear differential equation, and it is also known as an autonomous equation because it is independent of t. Now, a claim here is that the point A, if you have a point A that represents a stationary state or an equilibrium state, that represents a stationary state or an equilibrium state if f of A is equal to 0. So mathematically, the criterion is that the point A represents a stationary state if f of A equals 0. Now let's examine that. So when we, as I just said, when we talk of a stationary state, if we have a diagram of x dot versus x, the stationary state is represented by, let's say, a point like A. So for the stationary state, we have x dot equal to 0, and because x dot is equal to f of x is equal to 0. And because it is at point A where x dot is 0, so this x equal to A here should satisfy the equation. So that is why we have f of A equal to 0.